The Hairy-Ball theorem states that for any continuous vector field on the surface of the sphere, where every point is assigned to some vector within its corresponding tangent plane, there will always be at least one point that is assigned to the zero vector. This theorem gets its name from one of its direct applications. If you have a ball covered in hair and you try to comb it so that every hair lays flat, it is impossible without leaving one hair sticking upward. We can consider our ball to be the surface of the Earth, and we can consider the vectors to be the direction of wind flow. The Hairy-Ball theorem tells us that one of these vectors must be zero. That means, at all times, there's some place on Earth where there is no wind flow at all. On a circle, there does exist a continuous tangent vector field where every vector is non-zero. The theorem works for the normal sphere, but not the circle. This is because of their dimension. We say that the normal circle is a sphere of dimension 1, because it's really just a line curled up where its ends meet. The sphere has dimension 2, because if you were a small ant living on its surface, it would seem like you're living on a flat two-dimensional plane. The key difference between these two objects is that the one sphere has a one-dimensional hole in the middle, and the two sphere surrounds a two-dimensional hole. The Hairy-Ball theorem relies on the fact that the sphere surrounds a hole of even dimension. As a result, this theorem can be extended to any even-dimensional sphere, but it does fail for every odd-dimensional sphere. A proof of this theorem relies on tools from algebraic topology.